Okay, today we're going to talk about GUIs, and this is sort of long in coming because I can understand why it might be a little confusing or less than satisfying to develop apps the way that we have. We have been developing apps, or we developed our business logic in classes, but we did not have any GUIs to attach them to. For the most part, any application that you develop is going to have some sort of GUI associated with it. That may not be 100%, but certainly the majority of things will be that way. And in most cases, you have clean separation between what I'll call the business logic which probably is better put problem domain logic, because you could be talking about a game that isn't really business, but our GUI. Oftentimes there's a third layer, which is a database layer. And at times this might seem needlessly complicated, but it really isn't, because the more that you can separate functionality and have each class only interested in doing one thing and handling one thing, the better it will be. So for example, your next assignment, you're to develop a GUI for the pizza classes that I have. Those are going to stay mostly the same. You're going to have the pizza class. Have the order class. These are your business logic or problem domain logic. We'll then have a GUI that will talk to these classes. Create a pizza object. We'll set its properties. We'll add that to the order. Then it will ask the order for the amount of the order, the cost of the order. Okay? But none of that logic is going to be in the GUI. That's going to stay in these objects and these classes. Now, our first examples are going to be with GUI only, and they're going to do some real simple things just because that's how we want to start, by doing real simple things. But this week we'll be covering the very simple things of GUIs, and possibly by the end of class today, if not class next week, we'll talk about integrating the GUI with the classes. So let's look at a GUI. By GUI, I mean graphical user interface. By the way, before we had this GUI, we sort of had classes that sort of served the role of the GUI. So any of the first several assignments, you had unit test classes. And the idea of that is we want to be able to test our business logic classes without having to write a GUI. And therefore, any interaction, any error message to display, and so on, should take place in the GUI, and it should take place within the test classes. This is just going to return an error message to whoever called it if there is an error. So let's look at our first GUI. Pretty simple. These examples are available on Canvas. Was it in the desktop folder? Some of these get zipped up a bunch of times. That's why they are so many directories deep. I do apologize for that. All right, here we are. We have our first GUI class. And the GUI is a class as well, just like all the classes that we have. All our code in Java lives in a class, one class or other. So I'm going to compile this. Going to run it. Now this takes the place of our unit test class. You can still write the unit test class, by the way. And it may be a different person's job in a larger project to write the business classes and to write the GUIs. Maybe someone specializes in developing Java GUIs. And maybe your responsibility is just to write the business classes. You still might write a unit test class to test all your stuff out before turning it over. It does get complicated when you have this sort of structure because there could be a problem here. There could be a problem in one of these, or the problem could be the way that they communicate. So when you add more components, it adds a lot of power to systems, but it can make some things a little harder to figure out, a little more complex. So our GUI, first GUI, not first UI. All right, we have here GUI that asks for the temperature in centigrade. So I'm going to type in the temperature in centigrade. I'm going to type in 12 degrees centigrade, and that is 53.6 degrees Fahrenheit. I'm going to test this to make sure it works. I'm going to type in 0 centigrade. That should be 32 Fahrenheit. 100 centigrade should be 212 Fahrenheit. And negative 40 centigrade should be negative 40 Fahrenheit. And voila, it works. Now, again, in this example, we have everything in the first GUI class. A better example or more realistic example is where we would have the temperature conversion in a different class than this. I believe we're going to see an example of that, like I mentioned before, either next week or possibly later in today's class. All right, let's look at the code for this now. All right, first of all, we're importing some classes. We're importing some packages. Java Swing. GUI in Java can be done several ways. One of the ways is with a set of components called swing components. And those swing components take advantage of an earlier form of UI, which is called Java AWT, which don't ask me what those letters stand for because I don't know, right? So we import these at the beginning. This will import all the swing components like JLabel, JTextField, JButton, and JLabel. This will implement the action listeners and events. In other words, give the ability for our code to respond when the user interacts with the page, such as the user clicks on the button. All right, properties on this page. We declare as properties on this page all of the different components we want for our page. If I was doing this example real, I might have started off by drawing what I want my screen to be. Enter temperature, centigrade, there's a text box, there's a button, and the answer goes here. This is what's called a label because the text doesn't typically change, or rather, I should say, the text is not entered by the user. It just displays on the screen. And the text can change, but your program has to change it. We then have another label for this. This is a text box, and this is a button. Now, one thing we're not going to be too concerned about, at least not at first, is laying out these pages. All right. Our goal in this class is to make you familiar with the classes that happen in Java user interfaces and not necessarily devote the time to develop, perfect looking GUIs or great looking GUIs. We're more focused on the functionality of them. So if you notice, we have 4 things on this page. Label, or 2 labels, a text box and a button. Well, that's what corresponds to these things. Text field, not text box. Our first label, called label temp, and it says enter temperature in centigrade. Constructor of the label accepts a single string argument, which is the text that we want to appear in the label. txt temp accepts a single number as an argument. That is the size of it. Size in terms of size displayed, it actually can carry more space than that. I think you can only, I think you're restricted to numbers. I think we can put a bunch of numbers in here. But you notice the physical size of it is roughly enough for 4 characters plus or minus, keeping in mind that some characters are bigger than other characters. That's what the number means. We have a button called convert, which accepts a string argument in the constructor to be the text on the button. We see the button's text is convert. And finally, we have another label that we're going to put the results in. Now, how do you remember all these things? Well, remember the things that you do a lot. Making text boxes a certain size, making buttons, making labels. Should be pretty, you should have those, memorized so that you can do those quickly. But you can always look things up. And you get this, which is the program specifications. This will tell you what attributes are available. This will show you a summary of the constructors. A label, an empty constructor constructs a label with no image and no text. Actually create a label that has an image in it. We're not doing here. We can do an image and the horizontal alignment of it, if it's right or left. We can create a label with the text. We could create a label with text, an icon in a horizontal alignment, or with text and horizontal alignment. What if you don't know that it's JLabel? Well, Google Java swing label. And that'll give you tutorials that will show that it's actually the JLabel class. What if you don't know what the component is? For example, for your next assignment, a radio button would be useful. Well, I could type in JSwing components, and it will show a list of the components that are available. JButton, JCheckbox, JCombo box, JList, JMenu, JRadio button, JSlider, JSpinner, JText field, JPassword field. limit yourself to what I talked to in class. If you want to make your user interface more functional, by all means, look for the swing component and integrate that into your page. All right, so we've declared these. These, by the way, are, so to speak, floating in space. All right. They are floating in space in that we have not yet put them on a screen in any particular order. Now, that's the attributes of this first GUI. It extends JFrame and it implements Action Listener. We'll come back to that in a second. The first thing I want to do is I want to cover how this displays. Then we'll look at the Action Listener part of it. The main method simply says, create a new instance of this first GUI class. Remember, when we run something, when we're running it on the command line, we're calling the main method in it, which is a static method. A static method means that no instance of the object is required. So we don't create on the command line an instance of the first GUI object. We simply run the main in the class, and that creates an instance. This thing right here, the JFrame. So what gets run? Well, the constructor gets run, the empty screen constructor. First thing we do is we make it visible. If we forgot this, we would create that window, but a window wouldn't be visible. When might you want to do that? Well, you might have a window a help window that you want to create and initialize, but you only want it to appear when the user does something. Maybe does something in a different window. Set default close operation. This tells us what we want to do when we close the window. In this case, when we close the window, we're going to exit the program. I'm creating a JPanel object. A JPanel object is an object that is sort of a wrapper around these other components. So we have a couple of things. We have I'll just indicate them by a label, by a letter. We have a label. We have a text box, text field. We have a button, and we have another label. We have a panel, which is a way to group things together. And we have a JFrame. What we're going to do is this. We're going to put each of these controls in the panel. If we displayed the window at this point, it still wouldn't show anything. I'll go in and I'll play around with this a little bit, and you'll see what I mean. We'll then we'll put that panel inside the frame. And that's what actually makes this a screen that can work. By us putting into the panel, or into the frame, the panel which contains all these individual controls. Now, by default, the orientation is going to be horizontal. We'll see other examples where we could create a panel that's orientation is vertical. But by default, if we don't specify anything else, the orientation is going to be horizontal. All right. So we've made the window visible. If we forgot this, let's see what happens. program's running, but, oh, it actually does show. Interesting. Guess we don't, strictly speaking, need to set it visible, but we did that anyhow. Notice when we close it, we set the default close operation to exit the program. We create a panel. We add to the panel our different components, which are these: the label, the text field, the button, and the results. The order matters. This orients it horizontally. So the first thing we add is the label for temperature that says enter temperature in centigrade. That will be entered, and it will be the leftmost item in the panel. TXT temp will be the next one. The button will be next, and the results will be next. If we switch these around, for example, put this here, it compiled it. Oh. Doesn't matter if I make it visible or not. I must have forgot to save it or compile it or something the last time. Because if notice, if I set it invisible, it just runs an exit. If I make it visible, and when it runs, that seemed weird to me, but I didn't want to take time to investigate it. How it appears, but notice that it's in a different order because we changed the order of these instructions to put the text for temperature over here after the results. It'll still work the same. I put in 32 degrees and click convert, it'll display that is 86 degrees Fahrenheit. So the order matters, and the order with the default orientation to say, is it going to be stacked horizontally or stacked vertically, and what order are these things going to appear in? So we added all those four things to the panel. This adds the panel to the frame. Frame is like a picture frame. All right. Picture frame can contain a main panel. We grab the content panel and add to it our panel. So that takes and puts this panel with four things into the Windows main panel, and therefore it displays. Recompile it because I changed the order again. Save it. All right, we're back to our normal order. Put the panel within the content frames main panel. Now we can do the conversion. If we forgot to do that, then guess what? We have these four things added to our panel, but that panel isn't associated with any window. It isn't associated with any frame. And therefore, we're going to get an empty screen here. Sure enough, we have an empty screen. So we have these controls. Remember, if we don't do anything, if we don't create that panel and add it to it, we get a blank screen. Just creating these things doesn't put them on the screen. It creates those objects for us to do with what we want. We could have some of these appear in one window, some of these appear in a different window in a more complex user interface. But here we're adding all those things to the panel. Then we add the panel to the frame's main content pane. And then we set the size. My allergies are really working up today. It's kind of feel nasty. All right. It simply sets the size. It sets it as 800 width, 100 height. Could probably make it look a little more reasonable by doing 400 by 400. There we go. Now, we didn't do much to control the layout other than to add a panel which was oriented horizontally by default. Notice that as we expand the label, as it goes beyond, as we add that extra label and we expand the output, since there's no room horizontally, it appears underneath. Get big enough, then it appears by side. All right. Now, the one thing that we have not covered is we have not covered how the button works. Because if we run this, it sits there until we enter a value and press the convert button. Then it does the mathematics. All right. This is called event-based program. And this is what makes programs interactive. In other words, an event happens, and often that event relates to something that the user does. The user clicks on a button. The user presses a key. The user puts their mouse over something. All these things are examples of events in different kinds of programming. In this case, we have the event of the user clicking the button. Now, there's special classes that are called listeners. And these classes listen for events to happen. They listen for events to happen within a certain element on the screen. So what element of the screen are we interested in the event? We're interested in the button. So when the user clicks the button, we want something to happen. Therefore, we need a listener object that is listening for that event to happen. If we did not have that in there, it wouldn't work. This code right here adds the listener to the button. See, we have the name of the button, btn convert, and we add an action listener to it. So that's what adds a listener to it. If we comment that out and run this, guess what's going to happen? We have our page or our screen. So used to doing web development that I keep saying pages. But when the user clicks the button, nothing happens. Why not? Because nothing is listening for that event to happen. In other words, that button has not had an action listener event added to it. This adds the action listener event, or adds the action listener class to this button. So the argument here is going to be the class that is going to be listening for something to happen. In our case, we say this. What does that mean to say this? it means this object. In this case, this first GUI object is going to be listening to the button it's on itself to see when the button is clicked. So we assign this very object to contain the code that handles when that button is clicked. We're able to do that because this JFrame, or this first GUI, extends JFrame and implements action listener. If we eliminate this implements action listener, we can't do that. We try compiling this, we're going to get an error. And it tells us, incompatible types. First GUI cannot be converted to an action listener. All right. Action listener, we've seen the word implements before, and we've seen it before with interfaces. So this class implements the action listener interface. What does it mean to implement an interface? It means it can serve in the role of that particular thing. We want this object to serve in the role of the action listener. Now, what does it mean to implement an interface in addition to that? It means that every function that's included in action listener has to be included in class that implements it. So let's Google and let's see what methods are included in action listener. There's only one. Action performed method. And that is what happens when the user interacts with that control. In a case of a button, it occurs when the user clicks on the button. Actually, when the user interacts on it in any way, but specifically, in our case, it clicks the button. Now, I take that back. It's not when the user interacts in a certain way. It's when the user interacts in a way that that control can handle, right? If that makes sense. A button is meant for clicking, so this is only going to process when the button is clicked. And this action performed method accepts an action event argument, which means that when the button is clicked, details about the event are going to be put into this action event object, and we can use that to sort of tell what's going on if we need to. In our case, we don't really need this because our example is simple enough so that we know we always want to do the same thing when the button is clicked. We want to get the value of the text box, do the calculation, and display the results. Sure enough, in this, we have an action performed that accepts an action event. So when this is clicked on, due to the Java structure, automatically this is going to get called because we've assigned this object as being the action listener for button convert. This is the code that's going to get called when we click on the button. And it's going to get past this argument action event, even though we don't really use it. Well, what does our code do? Well, creates a variable for centigrade, creates a variable for Fahrenheit. It tries to get the value of the text box and turn it into a number. Notice it's in a try block. What could possibly go wrong? Well, what if the user enters in something alphabetical and not a number? In which case, this is going to throw an exception, and we're going to display we're going to change the label's text to invalid input. Assuming we can do the conversion, we continue on and do the calculation of Fahrenheit based on this rule. And then we set the results text. to whatever Fahrenheit is plus degrees Fahrenheit. Forgot to resave it. Type in something numeric, version works. We type in something alphabetical, and we get invalid input. Why? Because an exception was thrown when we try to convert that string to text field, which means we can put any kind of text in it. But if we want to treat it like a number, we have to convert it to a number. And if that conversion fails, an exception is thrown, and instead we display invalid input in that box, that label. Here's a thought exercise. What happens if I remove this function? I'm going to cut it out. I'll give you a hint. It's nothing good. What's going to happen is when we compile it, we are going to get an error. First GUI is not abstract and does not override abstract method action performed. All right. We've set up here that this first GUI implements action listener. That means it has to have all the functions that are declared in the interface action listener. What is the function declared in action listener? That action performed function. So without it, we get a compile error. What if we forget to put this in? Same thing. It's not going to recognize that as the correct function. We have not implemented the interface, and therefore we get a compile error. So let's review this. This describes all the components on our UI. When we start up this, when we run this object from the command line, main gets called, it creates an instance of this object, therefore the constructor gets called. Makes the page visible, says when we click the close button to exit this program. Creating a panel, which is sort of a holder for all the things we're going to put on the page. By default, the orientation is going to be horizontal. Button convert listener, add action listener. This means that this class contains a code that is going to get executed when the button is clicked. And that code is going to live in action performed. All right. If we had another button on the screen that's saying maybe converted Fahrenheit to centigrade, we could use the same action listener, but then the action listener would have to get tricky and use the event to figure out which button got clicked. But we're not going to do that in this example. Well, what this does is this says when the button gets clicked, this object contains the code that's going to handle it, and the name of the function that's going to handle it is action performed, because this is an action listener. We add our 4 components to the panel. We add the panel to the main content frame. We set the size, and we're in business. When the button is clicked, we try to grab the value from the text field. It's either correct or not correct. By correct, I mean it either is a number, can be converted to a double, or not a number. We do the calculation. Or rather, if it's not a number, we throw an exception and set the label to that. Otherwise, we grab the value from the text box, do the math, and set the label results to being the answer that we converted to Fahrenheit. Now, this is a pretty simple example, doesn't involve any other objects. As I said before, more advanced examples would include other objects, because the GUI shouldn't be doing any of the work itself. Even in this case, this really should live in a business class. But I want to keep things simple the first round of this, so I put the code in here. Now, I have a second version of this. We'll spend a minute looking at, we'll probably look at it again next time. And functionally, I think it works the same, maybe not. I really don't remember, we'll find out. Yeah, here we do have the two buttons. Notice it's organized vertically. So we put in a number. 22 centigrade to Fahrenheit is 76 or 71.6 degrees Fahrenheit. We type in 12 Fahrenheit to centigrade, says negative 11.11 degrees centigrade. So we have two buttons. We could have one listener that handles both of them, but for simplicity's sake, I made there two listeners. I'm going to point out the key things in this example, and please take the time to study this example, and we'll go over it in more detail next Monday as we go over another more advanced UI example. Part of it's going to look the same. We have our stuff. It's going to be on our screen. Table, two buttons now. Text field, results. We import the same things, but we do import something called a border layout. When we click main, when main runs, we create a first GUI, sets the close. Here we're creating two panels. One panel is going to contain the buttons, and by default they're going to be oriented horizontally. The other panel we're creating vertically, which means that the label, text, panel with the buttons, and results are going to be all stacked vertically. So if we look at this, the label, text field, buttons, label with the results are all stacked vertically. We do that by setting the layout of that other panel, the vertical. By default, it's horizontal. So this panel contains two things in it, and we add that panel to the bigger panel, and then we set the content pane for that. Now, where this gets a little more complicated is the way that we're creating the listeners. Notice I no longer say that this implements action listener. I say that the first button has a new listener called C to F. Well, inside this class, we have another class called C to F, and that implements the action listener. And it, of course, has the action perform method. This is called an internal class. It's declared inside of another class. It's actually part of that class. If you notice, when we compiled it, we actually got a couple of class compiled object code that look a little goofy. And this one represents the one for the C to F class. I do this two different ways in this example. It doesn't mean that you would have to do it two different ways. You pick a way that works for you and that's fine. Whatever makes more sense to you. I did it two different ways just as a demonstration. So one way you can do it is with an inner class. The first way we saw is by having our user interface implement action listener and do everything inside of one class. The second way we can do it is by having an internal class that is the action listener for one of the buttons. And the other thing is what's called an anonymous class, where we actually create a class smack dab in the middle of our instruction. Add action listener, a new action listener that contains this function. If that's a little confusing to you, don't worry about it. We'll go over this a little bit more next time along with our other example. All right, if there are no further questions, that's all I had for today. Please feel free to visit me during my office hours. And if you have any questions at all, let me know either there or email me. We'll talk to you next week.